Hello everyone, welcome to Earth Archives. Please take a moment to subscribe, like, comment and share this video. Also, don't forget to turn on the notification bell. Thank you. Today's topic is Dmitri Mendeleev, the creator of the modern periodic table. Many humanities students may recall one of their most painful memories when studying chemistry and physics, memorizing the periodic table of elements. Helium, neon, argon, krypton, xenon, radon. Just memorizing them seems like a nightmare, right? Let alone applying them in an exam, it feels almost impossible. However, for physicists, this is the culmination of a lifetime of work. Today, let's take a look at the history of the periodic table. Today, we all know that elements and atoms are the two fundamental pillars of modern chemistry. Since ancient Greece, both elements and atoms have been defined as the smallest units of matter that make up everything in the natural world. Since they are the basic building blocks of all matter, chemists have long dreamed of mastering them to truly understand the mysteries of the universe. Earlier, we mentioned the French chemist Antoine Lavoisier, who in the late 18th century initiated the chemical revolution, helping the world gradually understand what truly constitutes an element. By the early 19th century, John Dalton proposed the atomic theory, establishing atomic weight as essential data for chemical reactions. Between 1815 and 1816, the British chemist William Prout observed that the atomic weights of known elements were all whole number multiples of the weight of a hydrogen atom. In 1829, the German chemist Johann Wolfgang Dobereiner proposed the triad rule, grouping 30 of the 53 known elements into three groups. In 1862, the French chemist Alexandre-Émile Béguier de Champ-Courtois built upon the research of Italian chemist Stanislao Canizzaro, 1826 to 1910, who had presented a paper on the periodic table of elements at the French Academy of Sciences in 1858. Champ-Courtois used atomic weights as a foundation for his work and proposed that elements be arranged by atomic weight in a spiral pattern called the telluric helix. This pattern was named after the element tellurium, which was placed at the center of the spiral. In 1863, the British chemist John Alexander Rayner Newlands began studying the periodicity of chemical element properties. 2 years later, inspired by Dobereiner's triads, Newlands arranged the 61 known elements by atomic weight and discovered that every seventh element showed similar properties, much like the notes in a musical scale. He called this observation the law of octaves. In 1864, the German chemist Julius Lothar Meyer published Die modernen Theorien der Chemie, Modern Theories of Chemistry, in which he classified 28 elements into 6 groups based on their chemical bonding. However, in 1870, Meyer also arranged the elements by their atomic weights to reveal periodicity. Now we come to the main figure of today's episode, Dmitri Mendeleev. On March 6, 1869, at a meeting of the Russian Chemical Society in St. Petersburg, a paper was presented on the relationship between the properties of elements and their atomic weights. The paper was written by Dmitri Mendeleev, although he was unable to attend the meeting due to illness. His colleague read the paper on his behalf. Later that same year, Mendeleev edited and published the paper in German as a 2-page article titled On the Relationship Between the Properties of Elements and Their Atomic Weights in the Zeitschrift für Chemie, Journal of Chemistry. In this article, he included the first version of the periodic table. Mendeleev was born in the small town of Tobolsk near Siberia, although his surname actually came from the name of a local landowner. His father was a teacher, and his mother came from a wealthy merchant family. The youngest of 17 siblings, Mendeleev was raised in the Russian Orthodox faith. His mother encouraged him to patiently explore the divine and scientific truths. Mendeleev's father lost his job due to blindness when Mendeleev was young, and his mother was forced to take on the responsibility of supporting the family. In 1849, Mendeleev's mother took him from Siberia to Moscow with the goal of enrolling him in Moscow University. However, he was rejected. They then moved to St. Petersburg, where in 1850 he entered the Central Pedagogical Institute for his studies. After graduating, Mendeleev contracted tuberculosis, which forced him to move to the Crimea on the northern coast of the Black Sea in 1855. He spent 2 years recovering there and fully regained his health before returning to St. Petersburg. Between 1859 and 1861, Mendeleev studied liquid capillary phenomena and the principles of spectrometers in Heidelberg. In 1861, he published a textbook titled Organic Chemistry, which earned him the Jammadov Prize from the Petersburg Academy of Sciences. By 1863, there were 56 known elements, with new elements being discovered at an approximate rate of 1 per year. Other scientists had already confirmed the periodicity of elements. For example, John Alexander Rayner Newlands, described the law of octaves in 1864 based on relative atomic weights and predicted the existence of new elements like germanium. While this concept faced criticism, it wasn't until 1887 that the Chemical Society officially recognized its validity. In 1867, Mendeleev became a professor and wrote Principles of Chemistry, a textbook that would become a definitive authority in the field. The book was published in 2 volumes between 1868 and 1870 and was originally written as a course textbook. It was during the process of organizing the textbook that Mendeleev began categorizing elements based on their chemical properties. It was then that he noticed a pattern that led him to hypothesize the periodic table. He famously claimed that he conceived the arrangement in a dream. "I saw a table where all elements were placed in their correct positions. Upon waking, he immediately wrote it down, with only one place in the table needing adjustment." However, due to the limited information at the time, Mendeleev was unaware of earlier efforts to create a periodic table in the 1860s. He added elements based on this pattern and developed his own expanded version of the periodic table. On March 6, 1869, he delivered a formal presentation to the Russian Chemical Society titled On the Dependence of the Properties of Elements on Their Atomic Weights, in which he described the elements based on their atomic weights, now known as relative atomic masses, and their valence. Soon after, Mendeleev published the periodic table of all known elements in a Russian journal, also predicting the existence of several new elements to complete the table. A few months later, Lothar Meyer published a nearly identical table in a German journal, clearly having beaten Mendeleev to the punch. The publication of Mendeleev's periodic table in a German journal helped spread the concept of the periodic table and contributed to his growing reputation. In 1859, he went to Heidelberg University to study under the renowned chemist Robert Bunsen, 1811–1899. The following year, he had the opportunity to attend the Karlsruhe Chemical Conference, where he learned about Avogadro's law, that under the same temperature and pressure, equal volumes of different gases contain an equal number of molecules. This law proved to be highly influential when Mendeleev was developing his periodic table. Additionally, Mendeleev proposed changes to the known properties of some elements. For example, uranium was generally thought to have a valence of 3 and an atomic weight of about 120 at the time. Mendeleev realized that these values didn't fit his periodic table, so he adjusted the valence to 6 and the atomic weight to 240. The modern value is close to 238. Did Mendeleev make mistakes? Yes, of course. For example, he noticed that the atomic weight of tellurium was higher than iodine's, but he still placed tellurium correctly in the table. He predicted that the atomic weight values then accepted were incorrect. Some scientists dismissed his prediction of missing elements, but when gallium, Jr., and germanium, Ja, were discovered in 1875 and 1886, respectively, it proved him correct. These elements perfectly filled the gaps in the periodic table he had predicted. Mendeleev's work earned him widespread recognition throughout Europe. In 1882, he received the Royal Society's prestigious Davy Medal in London, and in 1892 he was elected a foreign member of the Royal Society, Formem RS. In 1893, he was appointed director of the Russian Bureau of Weights and Measures, a position he held until his death. In 1905, Mendeleev was elected a member of the Royal Swedish Academy of Sciences. The following year, the Nobel Chemistry Committee recommended him for the Nobel Prize in Chemistry, to be awarded in 1906 in recognition of his discovery of the periodic table. Although the chemistry section of the Swedish Academy supported this suggestion, the Academy was supposed to approve the committee's selection, as was customary. However, during the full Academy meeting, a dissenting member of the Nobel Committee, Peter Clausen, nominated Henry Moissan instead. Furthermore, despite not being a member of the Nobel Chemistry Committee, Svante Arrhenius, a highly influential figure in the Academy, also urged the rejection of Mendeleev's nomination. His reasoning was that the periodic system was too old to be considered a discovery worthy of the 1906 Nobel Prize. Contemporaries suggest that Arrhenius's opposition was partly due to Mendeleev's earlier criticism of Arrhenius's dissociation theory, leading to personal animosity. After intense debate, the Academy narrowly voted in favor of awarding the prize to Moissan by a single vote. Mendeleev was again nominated in 1907, but once again, due to Arrhenius's opposition, the nomination failed. In addition to his work on the periodic table, Mendeleev also conducted research on petroleum, contributing to the establishment of Russia's first oil refinery. He was among the first to recognize the importance of petroleum as a raw material for petrochemical products. He famously remarked that burning oil as fuel was like burning banknotes to light the stove. Mendeleev passed away in 1907 at the age of 72 in St. Petersburg due to influenza. His last words to his doctor were, "Doctor, you have science, I have faith," possibly referencing a famous quote by Jules Verne. Beyond his work on the periodic table, Mendeleev was praised by fellow Russian chemist and science historian Lev Chugayev, who described him as a genius chemist, an outstanding physicist, a researcher in fields like fluid dynamics, meteorology, geology, and chemical engineering, and a thorough expert in both chemical and industrial technologies, as well as in economics. Mendeleev was also one of the founders of the Russian Chemical Society in 1869 and was committed to advocating for protectionist trade policies and agricultural theories and practices. Such praise for Mendeleev seems well-deserved. One of the most interesting stories about Mendeleev, however, involves Russia's famous vodka. The reason vodka was standardized at 40% alcohol by volume is often attributed to Mendeleev. For example, advertisements for Russian standard vodka claim, "In 1894, the greatest scientist in Russia, Dmitri Mendeleev, received a decree to establish the imperial quality standard for Russian vodka, and the Russian standard vodka was born." Other sources refer to the highest quality Russian vodka approved by the Royal Government Committee led by Mendeleev in 1894. But what's the true story? In fact, the 40% alcohol standard for vodka was introduced by the Russian government in 1843, when Mendeleev was only 9 years old. While Mendeleev did indeed become the head of the St. Petersburg Bureau of Weights and Measures in 1892, and it later became a government agency, its role was to standardize trade measurement instruments, not to set production quality standards. Mendeleev's doctoral thesis in 1865 was titled "On the Combination of Alcohol and Water," but it dealt exclusively with alcohol concentrations above 70% for medical purposes, and he never wrote about vodka. This means the connection between Mendeleev and the 40% vodka standard is largely a myth, not supported by any actual historical documentation. Beyond the widely known periodic table published in the Zeitschrift für Chemie, Mendeleev also published at least 7 versions of the periodic table between 1868 and 1872. In the 1940s, the lanthanide series, elements in the 4f electron orbitals, and actinide series, elements in the 5f electron orbitals, were discovered. The modern periodic table that we use today started to take shape around 1950. Although many versions of the table were proposed in the years before, most of which were eventually discarded. As for the hidden mystery behind the periodic table, why the chemical properties of elements correlate with their atomic weights, Mendeleev was unable to answer this question accurately at the time. However, as more elements were discovered and quantum mechanics developed, the puzzle surrounding the periodic table began to be unraveled. In 1897, British chemist J.J. Thomson discovered the electron through his experiments with cathode rays, breaking the long-held belief that atoms were indivisible. Soon after, American physicist Robert Millikan used his precise oil drop experiment to measure the mass and charge of the electron. In 1903, Ernest Rutherford discovered that radioactivity is caused by atomic disintegration. Then, in 1911, Rutherford and German physicist Hans Geiger revealed that electrons orbit the atomic nucleus. In 1932, James Chadwick experimentally discovered that, in addition to the positively charged protons, the atomic nucleus also contains a neutral particle, what we now call the neutron. This discovery gave scientists a much more complete understanding of atomic structure and laid a more solid foundation for the periodic table. Today, scientists view Mendeleev's periodic table, proposed in 1869, not so much as a scientific achievement, but as a new question. Why do the properties of elements exhibit periodic relationships with atomic weight? The answer to this question is electron configuration. When electron configuration is understood, it can explain the various properties of elements, and this sheds light on the reasons behind their periodic behavior. However, this understanding also stripped the periodic table of some of its earlier mystique. The electron configuration simply refers to the number of electrons arranged in various orbitals around the nucleus. The atomic weight is the sum of the protons and neutrons in the nucleus, and in an atom, the number of electrons equals the number of protons. Ultimately, the relationship between elements boils down to the numbers of particles involved: electrons, protons, and neutrons. The idea of mass and quantity forming a mystical or symbolic relationship lost its allure. Instead, it became clear that the periodic trends were driven by quantitative relationships, rather than the mysterious connection between mass and quantity that Mendeleev and his contemporaries once believed.